So this is ICP Chapter 3, is the second video. An old magic trick leads to new discoveries about the atom. Since ancient times, people knew that certain substances would change the color of a fire's flame. We saw this in a demonstration last week. I did a flame test in our room with the lights turned down. There were a lot of elements that burned orange. There was a couple that burned red. One was a pinkish purple color, and there was a green. This old trick became an important step in learning about chemical behavior. So chemists began analyzing the light that was emitted from a flame when the substance was added. Analyzing the light emitted from the substance as it is placed in the flame is known as a flame test. Some substances can be identified based on the color of the flame produced. For instance, before modern times, if something produced a green flame, it was probably copper. Experiments with flame tests led to a new question: why do substances have unique and different colors? If you take physics later in high school in a different class, or if you take it in college, we'll talk a lot about the properties of light. It'll be very in-depth. For now, we're going to keep it a little more simple. We will say that light can act like a wave. So all light travels at the same speed, which we call the speed of light. It's kind of the upper speed limit as far as we know in our universe. Each color of light has its own frequency and wavelength. You're familiar with a small portion of all the light in the universe. We call it the visible spectrum, and we abbreviate it Roy G. Biv. This is the colors of the rainbow. The rainbow has all of the colors that we can see, and other colors are some combination of those 7 colors. The visible spectrum is red, orange, yellow, green, blue, indigo, and violet. So one wavelength of light, or one frequency of light, will produce a certain color. The more individual colors you have, or the more individual wavelengths, these are kind of talking about the same thing here. We see wavelengths as color. The more individual colors of light that are present, the more it looks like white, which is somewhat backwards from what most of us would think, because if we've taken an art class, we mix red and blue and yellow paint, and we get something like a dark brown color. But when it's light, it's the opposite. When you mix yellow and blue and red light, you get something closer to white. The light that's produced by a flame test is unique because only certain wavelengths of light are produced. The specific wavelengths of light is called an atomic emission spectra. We'll get a chance to look at these in class. I have some special instruments where you can see it. Further advancements with electricity allowed scientists to study the atomic emission spectra using something called spectrum tubes. They are very similar to the light bulbs that you would see in most classrooms. tube filled with a gas. Electrical current runs through it. So we are using spectrum tubes and a spectroscope. So we use the spectroscope to analyze the light. The spectroscope shows the wavelengths as spectral lines, and it looks almost like a barcode for the individual element. And these are all pretty unique. So you'll see these in class, but what you might find is that an element during a flame test or using a spectrum tube will have a couple of red lines, maybe an orange line, maybe a blue and a purple over here. And this would be kind of the barcode for the element. It's a very unique signature, something that you'll see in depth soon. Bohr proposes a new model of the atom that tries to explain the atomic emission spectra and its relationship with electrons. Each element has this unique combination of spectral lines. Could the spectral lines have something to do with electrons? Are they somehow related? Bohr's model says that electrons can only exist in specific places, called energy levels. Thinking in simpler terms, I like to compare Bohr's model to a ladder. Each rung of the ladder, so each rung of the ladder is one energy level. So you'll see this more in depth on the next page. But if we have a ladder, here it is, I'm setting up my ladder. Here are the rungs, and these are the energy levels.